In this learning objective, we're going to start to learn some of the properties of this new logarithm function that we're talking about. So again, we're always remembering that logarithms and exponentials are always linked together. So the first thing we do is remember some things with exponents. When we had exponents, if you multiply the two exponents together, you actually just add the exponents to simplify. If you divided the exponents, or the exponentials, that means you subtract the exponents. And if you have this double exponent like this, you just multiply the two of them. All right, so these are exponent rules we've been using all year. But you have these types of things, you can combine multiple exponentials into a single one by combining the exponents in the right way. All right, so now since exponentials and logs are related, there's going to be some similar-ish rules for logs. All right, in this video, I'm just going to kind of give you the rules and we're going to use them. If you're interested in like where these rules came from and how they're related to the exponentials, I can explain that to you. But in the video, just to keep it a little bit shorter, I'm just going to give you the rules and then we'll start to use them in examples. All right, so here are the three major rules for logging. There's some other small ones that you kind of figure out, but these are the ones that we're mostly going to focus on. All right, so the first thing is, if I have two separate logs, again, it's important that they have the same base, because if they don't have the same base, you can't combine them, just like with exponentials. But if I have these two separate logs and I add them, adding two logs, I'm going to squish them together, and I'm going to multiply the two things that were on the inside. If I subtract two logs, again, I'm going to smush them together to a single log, and I'm going to divide the two things that were on the inside. And again, the first one is going to go on the top, and the bottom one is going to go on the bottom. All right, so addition leads to multiplication, which is kind of the opposite of exponentials. Subtraction leads to division. All right, the next one is one that isn't as obvious how it comes from the exponential ones, but it turns out if I have some exponent inside of a log, that exponent can jump out in front of the log to there. All right, so these are our three rules. Adding and subtracting logs, we can squish them together. If we have an exponent in a log, we can bring it to the front. And of course, these rules work both ways as well. So if I have multiplication, I can split it up. If I have division, I can split it up. If I have this exponent, I could bring it back inside. All right, so we're actually going to have to do both these, or sorry, all three of these rules in both directions for our examples. All right, so make sure you have those log rules written down, because we're going to reference them over and over again in these examples. All right, so we're going to combine the following, and whenever it says combine, you want your final answer to just be a single log. All right, so you have 2 log of A minus z log of d. All right, the first thing we're going to do is whenever there's a number in front of a log, like there is here and here, all right, z is a letter, but it's still representing a number, those we can bring inside of the logarithm. So the first step I'm going to do is rewrite this as log of a squared minus log of d to the z. All right, don't get confused because there's more letters and stuff. You're still just kind of moving things to a location. Doesn't matter if it's a letter or a number. And now I have these two logs. There's really nothing else going on except for I have these two logs and there's a subtraction sign between them. And we saw if there's a subtraction sign between logs, we can smush them together into a single log. And what we're going to do is we're going to take the top, or the first log value and divide it by the second log value. That z is an exponent. All right, and that's our final answer. So I was able to take this single log and rewrite it, these multiple logs and rewrite it as a single one, smushing them together. All right, this next example is going to be virtually the same, except for there's an addition sign instead. But the first step's still the same. There's a number in front of my log. I want to bring it in as an exponent. And it doesn't matter if it's a letter or a number, just bring it into the exponent. And I have to do that first because I can't combine these things if there was extra stuff around them. But now that there's just a single log here and a single log there being added, I can smush them together into one. And the addition sign means I'm going to smush them together and multiply the two parts together. All right, so that is the whole problem. All right, exponents first, bring those numbers as exponents. And then remember division and multiplication. Here's a couple more. for this learning objective, we're going to do delta math practice. And for some reason in delta math, they don't put the parentheses, so you'll see it like this. All right, remember there's kind of these parentheses here. You can write that down yourself if it helps you. All right, but the way you'll see it written is without the parentheses. All right, first thing I want to do is bring in this exponent, this 2. The minus sign is going to stay, and I get g squared. And then again, subtraction leads to division. The most common mistake students will make in this step is write it as this, because they remember that subtraction leads to division, so they divide the two separate logs. But this would literally just be turning a subtraction sign into a division sign, and the chances of that being true are really slim. All right, so try to remember that instead you're trying to take this into a single log. So writing it like this is a hint that it's not right, because you have two different logs, and that kind of defeats the purpose of having just one single log. All right, so when you see that subtraction sign, squish them together into one single log and divide the first divided by the second. All right, last one that I'll do, this 3 is going to come in. You get log of d cubed minus log of k. And there's no number in front of k, so I don't have to do anything with that yet. And there's a subtraction sign, so I divide. All right, the first one divided by the second one. So that's our final answer. And here's one for you to try on your own. Log of a minus 2 log of c. And here's the answer you get log of a divided by c squared. So again, the order, this 2 is going to become that exponent, and this subtraction sign becomes that division bar. All right, so here are some more examples, and now we're just doing the opposites. Now we want to expand. So we're going to take this kind of complicated thing inside a log and break it up into as many pieces as we can. So we're basically just going to do it in the reverse order of the last things we did. The first thing we see is that there's division or multiplication inside our parentheses. In this case, there's multiplication, x squared times y to the 5th. I can break that up into 2 separate logs. And again, multiplication inside our log is the same as addition outside. Now, each of these individual logs has an exponent, and our rule says if we have an exponent, we can bring it to the front. So it's going to be the 2 is going to jump to the front. Now we're just going to have an x in here. The 5 can jump to the front, and we're just going to have a y in here. And that's our final answer, because you can't get simpler than just having a single term inside of the log. All right, next problem, very similar start. We have 4x to the 5th. Again, there's no division, but there is multiplication because we do have 4 times x squared. So we want to see any multiplications or divisions that we have. So the first thing is that multiplication, we split into a plus sign between 2 separate logs. Log of 4, we can't do anything with, so we're just going to leave that. But log of x to the 5th, that exponent of 5 is going to jump to the front, and we get 5 log of x. All right, so again, just keep going until you get a single term inside of your logarithm, and that's how you know you can't get any simpler. All right, again, on delta math, they're not going to put the parentheses, but you can always just kind of remember that there's parentheses here. All right, this one is really similar to the previous one. There's 5 times x to the 4th. So we're going to have log of 5 plus log of x to the 4th. And so the exact same problem that we just did with different numbers. Log of 5 isn't going to change, but this 4 can jump into the front, become 4 log of x. All right, so just breaking up addition and subtraction. Actually, let's change this last one because we haven't done a division one. Let's just say it was x over y to the 5th. All right, so I'd say this was our expression. Now you see that there is a division bar. All right, there's a division bar. We're still going to break up our log into 2 logs, but we're just going to write the log at the top, so it's log of x. And because it's division, we're going to subtract log at the bottom. Right, so same thing we did with multiplication, except for instead of writing a plus sign, we write a minus sign. And then we remember that that 5 can jump out in front of the log, and then we're done. All right, so when you're expanding logs, break up the addition and subtraction first. Sorry, not addition and subtraction, the multiplication and division first. That turns into addition and subtraction. and then any exponents bring out to the front. All right, so here's the one for you to try on your own. Log of x to the fourth, y to the fifth. And here's the answer. You get 4 log of x plus 5 log of y. Again, the steps. Multiplication between these two things turns into that plus sign. This exponent jumps to the front. This exponent jumps to the front. All right, so there's 2, maybe 3 steps that you have to do to break this up into simple logs. All right, so for this learning objective, you're going to do delta math. You're going to do 5, where you can bind them into a single log, and then 5 when you do it in reverse and expand the logarithms. All right, there's going to be 3 bonus objectives, which just deal with more challenging problems of this type, basically when there's just more terms, more exponents, maybe a x, y, and a z. But those will be bonus objectives. All right, the ones that we covered in this video are the same type you'll have to do in your delta math practice.